In the previous lecture, we saw how and when to use computer properties. In this lecture, I want to show you how to use getters and setters with computer properties. Computer properties are getter only by default, but if you need to, you can also specify a getter. To do this, we actually need to change our computer property from a function to an object with two properties, get and set. These properties are functions that are invoked when we use the computer property to retrieve and update the value respectively. Let's begin to restructure the property. So, like I said, this needs to be an object now. So I'll specify get, which is a function, and similarly set, which is also a function. Now the logic to retrieve the property's value is going to remain the same, so I can simply copy the code from the old function right here. And now I can delete this function and paste it in here, reformat it a bit, and that's it. As for the set function, I'll actually add a parameter named new value here. As the name of the parameter suggests, it will contain the new value whenever we assign a new value to the computer property. Since I will be assigning the full name as a whole, I need to do a bit of splitting to accomplish the same behavior as before. I will also add an alert for this function so we can see when it gets called. Then I will simply split the value by space and assign the first part to the first name data property and the last part to the last name property. So let's go ahead and do that. First, I'll just add an alert, just so we can see what we're doing. Setting new name, and I'll just output the new value here. Now I'll split the value by space. So I'll say parts equals new value dot split and the space. And this dot first name equals parts at index 0. So I'll just take the first part. And for the last name, I'll say parts at an index that equals parts.length minus 1, so the last index. And notice that within the set function and the get function as well, I refer to data properties by using the this keyword as we've seen before. So, within the set function, I simply update the data properties as I did within the other event listener. So far so good. Let's now get to actually using these functions. The next thing I'll do is to add a new button, which will use the setter that we just implemented. So I'll go up here, I'll say button, change name with the setter, and I'll add an event listener for the click event. I'll just call it change name setter, just to be explicit. And I also need to add an event listener for this button. So I'll add this within the methods object. So I call it change name setter and an empty function for now. So to use our setter function, all we need to do is to assign a new value to the computer property as if it were a normal data property. So I can just say this dot full name equals, and let's say Mark Gonzalez again. Vue.js will automatically detect this and invoke the setter function. Let's be honest, this is pretty awesome, isn't it? So that's it. We don't need to do anything to invoke the getter function. This is done automatically when we access the computer property. So now it's time to see our code in action. So I'll run it. And when I click the new button, we see an alert displaying the name that we are setting, proving that our setter function is indeed invoked. If I close this dialog, we will see a new alert, this time from the getter function. This alert shows up because we just changed the value of the computer property, and therefore Vue.js will reactively update the DOM with this new value. And there you have it. That's how to use getters and setters with computer properties. Sometimes you may want to watch data for changes and react to them. Typically, all you need is computed properties, but there are some scenarios where you need to implement a custom watcher. Before we talk more about when to use watchers, let's first see an example of how to use them. We'll build a live search which returns search results as we type into a text input field. We'll simulate fetching search results from an API by using JavaScript's setTimeout function. I have already prepared the template as well as some data properties. All it does so far is to bind the value of the text input field to the search query data property. The search results will be stored within the results property, which will be an array of strings. To tell whether or not we are currently fetching search results, I will use an isSearching Boolean property. This is all something that we have seen before. I want to trigger a search whenever the value of the search query property changes. So how can I do that? I can use something called a watcher. Watchers are functions that are invoked whenever the values of the data properties that they listen to are changed. Therefore, we associate a watcher with a data property. Watchers are added within a property named watch, which is added at the top level of the Vue instance, similar to data, methods, and computed, for instance. This property should be an object with the same syntax as the methods object, but with one key difference. But let's go ahead and add the empty object, like so. While the values of the nested properties are indeed functions, the names of the keys must correspond to the names of data properties. So if we want to watch the search query data property for changes, we need to enter search query as the key of our watcher. Like so. This is how we tell Vue.js which data property the watcher is watching and thereby reacting to. Notice that I added a parameter to the watcher function. This is the new value for the data property, which is passed as an argument by Vue.js whenever the value of the search query property is changed. Just to show you that this function is indeed called whenever the data property is changed, I will log the new value to the console and try to type something in the text input. So, writing console.log and just logging the query. So now I'll open the console right here. I'll just clear it and run the code. And as I type, we can see the search query being output in the console. So let's just reset this. Alright, so with that part working, let's get to implementing the actual search logic. The first thing I'll do is to set the isSearching property to true to indicate that we are now waiting for search results to come back from the server. As with methods, I will use the this keyword to access the Vue instance from within the watcher function. Next, I will add a timeout and a run function after 500 milliseconds to simulate retrieving results from a server. So I'll say set timeout with a function in here and 500 milliseconds. Within this function, we'll first update the results property with the search results. But wait a minute, we cannot use this within this function as we are used to, because we are now in a different scope. Let's verify this by locking this to the console within our watcher function and also within the function that runs after a short timeout. So I'll go up here, console, log this, and I'll just copy this down here as well. So I'll open up the console, clear out, and run the code. Then I'll type a character. Notice how the first entry refers to the Vue instance, while the second one refers to the window object. So clearly we cannot access the Vue instance this way within the nested function. So how do we access our Vue instance? Actually, we have two choices. The first is to use an ES6 arrow function, because these functions bind the this of the scope in which the function is declared. To do this, all I need to do is to remove the function keyword and add an arrow represented by an equals sign and a greater than symbol. So let's do that. I'll remove function and add an arrow here. Clear the console. Let's try again and verify that this refers to what we would expect within the nested function. And if I type character here, we'll see that the Vue instance is now logged twice, which is exactly what we wanted. Let me just revert these couple of changes for now, because I want to show you the other way of doing it. So the other way is to use an old trick that assigns this to a variable, which can then be referenced within the nested function. So I will add a VM variable, which is short for Vue model, and I will assign this to it. And it's kind of a convention for naming Vue instances. So with this variable at hand, I can now access the Vue instance from within the nested function. Let's just log it to the console and ensure that it references what we expect. So I'll change this here to VM. And let's run the code again and type something. And as you can see, VM now refers to the Vue instance. So let me just clear out this debugging code, like so. So with that out of the way, we can now get back to actually implementing the search functionality. I will first set the search results to an array of strings containing JavaScript, PHP, and MySQL. So I'll use the VM variable for accessing the results data property, and I'll set it equals to an array of strings, first with JavaScript, PHP, and MySQL. The last thing we need to do is to set the isSearching property to false. So I'll do that here. VM.isSearching equals false. Let me just close the console. And let's see the code in action. So once I begin typing, we can see that a text is displayed stating that search results are being retrieved. And after a short moment, we see a list of search results, which is what we wanted. So what's the big deal, you might ask? Why couldn't we just use a computed property or an event listener? You could actually do the latter, but you cannot accomplish this with a computed property. The reason is that computed properties are synchronous and must return a value. An AJAX request or a timeout function in this example run asynchronously. And that's why we cannot use a computed property, because Vue.js listens for the return value of the function. As I mentioned, you could have accomplished the same with an event listener on a key-up event, for instance, but this has the disadvantage that you manually have to handle this event and call a method, instead of just listening to data changes. And if the data was to be changed somehow else, then our application would not react accordingly. You will typically use a watcher when you want to asynchronously react to data changes, often for expensive or long-running operations, such as AJAX requests. You also don't have to return anything within a watcher, as you do with a computed property. This being said, you should typically use computed properties whenever possible, unless you need to do something that cannot be done with a computed property. Now just an interesting fact to end this lecture off with. You can actually watch computed properties too, and not just normal data properties. It's time for a few exercises on computed properties and watchers. For exercise number 1, we have an array of movie objects, which we want to format a bit when outputting them. We could of course do this directly within the template, but we're not going to do that because we just learned about a cool new thing called computed properties. The movies should be output on a list, and the format should be the name of the movie followed by the release year within parentheses. You should add a computed property that returns an array of strings with this format. The second exercise is about adding a movie of your choice to the movie's data property, and then adding a watcher which outputs that movie in an alert dialog. I'll be back in a moment with my solutions, and I hope that you give it a try. Alright, now that you've had a chance to give it a go, here are my solutions. For the first exercise, I need to do two things. Add a computed property to reformat the data, and use a loop to output this reformatted data. First, the computed property. I will add the computed object first of all, down here in the Vue instance. So computed and an empty object. And within this object, I will add a property named formatted movies. Like so, which should be a function. Now there are many ways in which I could reformat the data into a string array, but I'm going to use a rather short and concise way of doing it, by using the array's map method. This method takes a function as an argument and invokes this function for each element in an array. It then creates a new array with each value that the function returns. Since I want to operate on the movies data property, I can call the map method on this array. So this.movies.map, and this method takes a function, and each movie will be passed as an argument, like so. Within the function, I can simply return the movie name, concatenated with the release year and closed within parentheses. So let's return movie.name plus a space, an opening parenthesis, and then within here I'll add the year, and I'll close the parenthesis once again, like so. The map method returns the new array, so all I need to do is to return this right here. So that's it for the JavaScript part of things. Now I can use this computed property together with the v-for directive to loop through the strings. So let's go up here, say v-for equals movie in formatted movies, which is my computed property. And here I'll just output movie. This should give me the correct result, and indeed it does. As for the second exercise, I'll begin by adding an event listener for the click event on the button. So v on click, and I'll name this listener add movie. The listener will be implemented within the methods object as we have seen before. So I'll just add this object and add movie, which is a function. Within this function, I'll simply push a new object to the movies array. So this.movies.push and an object. In here I'll add a name property. I'll say the Fast and the Furious, and the year was 2001. With that in place, it's time to add a watcher, which will react to changes on the movie's data property. Remember that the name of the watcher must match the name of the data property that it should watch, which is movies in this case. So I'll go down here. Let me just add some spaces so we can see what we're doing. I'll add the watch object. Whoops, it's supposed to be an object. And in here I'll add a movies watcher, which is a function taking the new value of the data property. So the function takes the new value of the data property as an argument and not the element that was just pushed to the array. Therefore, we need to retrieve the last element from the array in order to output its details within an alert dialog. So in here I'll say new movie, and I'll grab the last movie within the array at the last index, and I'll use this in my alert saying new movie.name plus from, and then I'll add the year, new movie.year, and was just added, like so. And that's it. Clicking the button should now show a dialog, and in fact it doesn't. That's because I missed an S here, so let's try again. And now we see a dialog displaying the movie name and the release year. So what happened here was that we first pushed an element to the movies array, which our watcher reacted to. And the watcher received the new value of the data property and not the element that was pushed to it. And that's why we needed to grab the last element within the array in our watcher function. In this lecture, we'll be talking about something called filters. Filters provide a way to perform text transformation, such as capitalizing letters or doing virtually anything we like. Filters can be used both within string interpolation, but also within the vbind directives expression. As always, let's dive straight into an example. So I have a message data property, which I output using string interpolation. Suppose I want to output the message in all uppercase letters. The first thing I want to do is to introduce a new top-level property on the Vue instance, namely the filters property. So let's add this object, like that. This property is semantically the same as the methods property, in that it takes filter names as keys and functions as the values. In this case, I want to add a filter named uppercase, so I'll use this as the key. The value is a function which receives the value to transform as its first argument. So I'll add this function and a value as the first parameter. And within this function, I have to transform the value being passed in as the first argument and return the transformed value. So I can return value.toString just to make sure we're working with a string and not a number, for instance. And on this I can call to uppercase, like so. There's just one more thing I want to do to this function, is that up here at the beginning I want to check if we do actually have a value. And if not, I'll just return an empty string. So this is just a small precaution. Let's say undefined is passed in as the value. Then our toString method invocation is not going to work and it's going to result in an error. So if this is the case, we just return an empty string and nothing is displayed. So at least that's better than our code failing. So using this filter is very simple. Simply add a pipe symbol after the string interpolation expression followed by the name of the filter. In this example, I will add a pipe followed by the name uppercase, matching the name of my filter. We'll now see the message being displayed in uppercase letters. What happens is that the evaluation of the expression before the pipe, message in this case, is passed to the filter as the first argument, and the return value of the filter is then output. Filters can actually be chained, so we could add another pipe and filter name after the one we have just added. The second filter would then receive the result of the first filter as its first argument. This is useful if you want to apply multiple transformations to your text, and this also allows you to keep filters very specialized, such that they only do one transformation each. There's one more thing I'd like to show you. Since filters are just JavaScript functions, we can actually use them as such. This allows us to pass in our own arguments in case we need some more flexibility. Let's say that we want our filter to take an argument that decides whether or not only the first character should be uppercased instead of the whole string. To do that, we first need to add the parameter to the filter and make a few changes to the code. So here I'll add a only first character parameter, which should be a Boolean value. And now we just need to restructure the code a bit. So I'll first take the part converting the value to a string. move it up here because I'm going to need to do this twice, depending on the evaluation of the Boolean. So I want to check whether or not the second parameter is true. So I'll do that here. If this is the case, then we only want to uppercase the first character of the input and leave the rest as is. So I can return value.char at index 0 to take the first character, and this character I want to convert to uppercase. So this right here just means that we are converting the first character of the string to uppercase. But I also need the rest of the string. So for this I can use the slice method with an index of 1. And since I haven't specified an end index, this is just going to take the rest of the string and concatenate these two. And if that if statement is not true, then I can take this down here, move it up, return value.to uppercase. And that should be all we need to change in the filter. So within the template, we can now use the filter as a normal function with parentheses and add our argument. In this case, I'll add true. And note that this argument is actually passed as the second argument. And this is because Vue always passes the value to transform as the first argument automatically. Now we should only see the first character being uppercased. If we change the Boolean to false, we should see the message in all uppercase letters. So we can pass any expression as arguments to our filter, be it the name of a data property, a shorthand if statement, or a string. So that's it for filters. That was pretty easy, right? Before ending this lecture, I just want to mention that filters are intended for transforming text. So if you need any complex data transformations, then you are usually better off using a computed property. That being said, let's solve a few exercises with filters. It's time for some exercises with filters. For the first exercise, please implement a filter named UW first, which transforms the first character of each word to uppercase. You can use JavaScript's split function to split the value into words. Then use this filter within the vbind directives expression so that when you hover your mouse over the paragraph, we see a title with capitalized words. As for the second exercise, take the filter from the first exercise and apply it to the string interpolation within the paragraph. Then implement a new filter which removes any spaces and chain these two filters together. Best of luck solving these exercises, and I'll be back in a moment with my solutions. Alright, I hope it went well for you. Here are my solutions. As for the first exercise, let's begin by implementing the filter. So I'll add the filters object as we did in the previous lecture. And as for the key, we'll say UW first as the name of the filter and a function with one parameter, which is the value to transform. And I'll just begin by checking if there's no value, return an empty string as we did in the previous lecture as well. And now I want to split the value into words. So I'll first convert the value to a string, and then I'll use JavaScript's split method with a space. So I'm splitting by space, and I'll store this in a variable named parts. So this is going to give me an array of strings. Then I can use the map function on this array. So parts.map, which takes a function. And we've actually used this method before in a previous lecture. And this function is going to be invoked for each element within the array. And the value I return within this function is going to be added to the array that's returned by the map method. So in here I'll say return word.char at index 0. So the first character, I'll convert that one to uppercase, plus word.slice at index 1 and the rest of the string. So essentially we're just converting the first character to uppercase and leaving the rest as is, exactly as we did in the previous lecture. So the result of this is going to be an array of uppercased words. So the only thing I need to do now is to join these words together by space. So I can say uppercased words dot join and a space. So now we're just gluing these array elements back together into a string. To use the filter within the vbind directive, we can simply do as we saw in the previous lecture. Using filters with the vbind directive is therefore no different than with string interpolation. So we just need to add a pipe here and the name of the filter, which is UW first, like that. So let's try to hover the mouse over the paragraph and see that it works. And as you can see, the words have been capitalized. As for exercise number 2, let's first implement a filter to remove any spaces within the value. And I will name this filter remove spaces. And as before, let's just start by checking for empty values. And removing spaces is pretty simple. There are more ways you can do it, but I'm just going to first convert the value to a string. And then I'm going to use the replace method. And in here I'm going to use a regular expression. So I'm going to add 2 slashes to denote the expression. And I'm going to match spaces. And to make sure I'm not just replacing the first space, I'm going to use the global flag here. And the replacement value is just going to be an empty string. As for the template, let's begin by first applying the UW first filter from the first exercise. Then to add an additional filter, we simply use the same approach as before and add a pipe, followed by the name of the filter, in this case, remove spaces. In this way, the filters are chained and the message is first passed through the UW first filter and lastly the remove spaces filter. If we take a look at the right hand side of the screen, we can see that both of the words have been capitalized and that the space has been removed. That's it. Now that we know how to use filters, let's move on to learning about styling elements with CSS. So far, we've seen quite a few examples, but let's be honest, they haven't been that visually appealing. In the next couple of lectures, we're going to see how we can apply styling to our elements and make things look just a little bit more interesting. We're first going to start out by adding inline styles to elements with the style HTML attribute. Since we're going to bind an HTML attribute, we're going to use the vbind directive again. I have added a simple div element in advance, which is 200 pixels in width and height. And the first thing I want to do is to set its background color to blue. So I'll begin by writing the vbind directive here and for the style attribute. And when binding to the style attribute, the expression can be either an object or an array. Let's begin by seeing what the object syntax looks like. The keys in this object should match the CSS style that we want to set. And the value should be an expression that resolves to a value. In this case, the key will be background color. So I'll add that, background -color. As in normal JavaScript, we need to enclose the key within quotation marks because it contains a dash. Note that I will use single quotes here, so I don't have to escape double quotes, as they would otherwise interfere with the HTML markup. So that was the name of the style that I want to apply to the div element. For the value, I can simply write red enclosed in single quotes as well. like this. So this will give us a red square. Of course, this is not all that useful because we defined the color directly within our template. If that's all we needed, we might as well just have added the style directly to the HTML style attribute. What's more useful is to actually bind to a dynamic color. Let's create a data property containing the color instead and bind to this property within the template. So I'll add the data object with a color attribute and I'll just write blue here. Now I just need to write the name of this property as the expression for the background color style, and the result will be the same, only blue. So if I go up here, remove the string, I'll just write color here and run the code. And now we see a blue square. Now of course this is not too useful either, because we have hard-coded the color within our Vue instance. But what this enables us to do is to change the color dynamically. And you guessed it, when doing this, Vue.js will automatically update the style, because we have now bound the background color style to the color data property. To show you this, I will add a button with a click event listener, which changes the color. So new button element with the text change color. And let's add a click event handler for the change color listener, which I will add in the methods object down here. Oops. And here I'll add the change color function. And within here, I'll just say if the color is currently blue, then I'll set it to red, and otherwise, else I'll set it to blue. And if I click the button now, we'll see that the background color of the div changes. As you can probably imagine, it can quickly become difficult to read if we add more properties to the object within the template. To solve this, we can simply move the data object to a data property and refer to this property within the template. So I will call the property styles. So I'll add it here. And in the process, I'll clean up the code a little bit because we'll no longer need the button that changes colors. So I'll remove that. And now I can change this expression here, and I can simply write styles. And I can also get rid of this event handler down here. So let's test it out. And we do see a blue square. Before proceeding, did you notice that we have a style attribute in pure HTML alongside the binding to the same HTML attribute? This works because Vue.js merges the styles on our behalf before applying the styles to the DOM. So the styles that are applied to the DOM are the result of merging the HTML style attribute with our style binding. The same applies when using classes, which we'll see in the next lecture. That being said, let's move the width and the height to the styles object as well, just to keep the styles in one place, and thereby make things a little easier to maintain. So width was 200 pixels, and the same for the height. And now I can remove them up here. And I should see the same result, and indeed we do. So much better. This is all great for simple examples like this, but what if we needed to make use of some other data properties to determine the styles? Perhaps we always want the width to be half of the height or something like that. Of course we could be lazy and just change the width to 100 pixels, but that wouldn't be much fun, would it? Since we cannot access other data properties from within our styles object, we need to do something else. Can you guess it? The answer is a computed property. So let's change our data property to be a computed property instead. So I'll go down here, I'll add the computed object. Basically, I'll copy the styles here. And I need to change it to a function, like so. And let's say height equals 200. And now I can return an array with these properties and copy these up there in the object. Sorry, I meant to return an object, of course. And as for the width, I can add a calculation here saying the height divided by 2. And here I can simply concatenate the height plus pixels. And running this code, we'll now see that the width is half of the height. The point is that you can either use a data property if your styles do not depend on one another, or a computed property if they do. I mentioned that it's also possible to use an array for the styles instead of an object. This is perhaps slightly less common, but let's take a look at how you can do it anyways. If we add an array instead of an object, this array should in fact be an array of objects, where each object uses the same syntax as we've just seen. The point of this is that you can override styles. So I'll add a new data property named moreStyles right here. moreStyles, and it's going to be an object. And I'll just make it add round corners to the div by using the border radius CSS style. So border radius, I'll set it to 5 pixels. And in the template, I can now add the 2 objects within an array. So I'll add square brackets here, and I'll add more styles. I could, of course, also have referred to either a data property consisting of an array or a computed property which returns an array. What this does is that it merges the 2 objects together. So if I run the code, you'll see that the div still has the same styles, but that it now also has round corners. This is because Vue.js merges the objects together, and it's worth noting that an object in the array takes precedence over any objects that are added before them. So if I were to change the background color to red within the moreStyles object, we would see that the background color changes to red, even though we had already defined it to be blue in the first object. So let's try that out for a second. So here I'll say background color, I'll set it to red, run the code, and the div changes to red. So I'll just remove this again. It was just to show you that what I said was true. Now, something interesting to note is that Vue.js automatically prefixes the CSS styles with any vendor-specific prefixes to ensure maximum browser compatibility. This means that when using inline styles like this, Vue.js got you covered, so you don't need to worry about using tools like autoprefixer, which can be difficult to use with inline styles. And with that, let's move on to seeing how we can apply styles with CSS classes. Now that we've seen how to add inline styles by binding to the style attribute, let's now see how we can use classes for styling. While it's convenient and sometimes necessary to use the style attribute, it's considered best practice to write CSS in external style sheets and apply styles to elements based on classes and element IDs. I have already prepared some simple CSS classes in advance, which you can see on the right side. Suppose that we have an array of shapes, which can be either a circle or a square in this example, and that each square has some common styles associated with it. We distinguish circles from squares by having an isRound property on each shape object. With this, I can make a div element which iterates through the shapes array by using the v-for directive. I'll just write that before we get into determining which classes should be on the div elements. So going to the template, say div class equals shape and v-for shape in shapes. Notice that we'll always add the shape class. Similarly to how we bound an object to the style attribute in the previous lecture, we'll bind an object to the class attribute now. So I'll just reformat this slightly. And I'll say v bind to the class attribute and an empty object for now. Now the syntax for this object is slightly different in the context of the class attribute. The keys of the object should match the class names, and the values should be an expression that evaluates to a boolean. If the boolean is true, then the class is added, and otherwise it will not be added to the DOM. Therefore, you can add classes to the object, even if you don't know if they are going to be added at runtime, something that we're going to do now. The first class that we will conditionally add is circle, so I will enter that as the first key within the object. As for the expression, I'm going to use the alias for the current iteration of the loop, which is shape. If the isRound property is true on this object, then I want to add the circle class. So I'll just do this like so. So if the isRound property on the shape object is true, then the circle class is added. If it's false, then the class will not be added to the DOM. Now we have checked if the shape is a circle, but we also need to check whether or not it's a square, and if so, add the appropriate class. So let's do the same for the square class, except that we need to negate the expression. So square, and I'll add an exclamation mark. I'll say shape.isRound exactly as before. With this, each div element will contain the shape class plus either circle or square. And let's run the code. As we can tell based on the styling, the first shape is indeed a circle, which matches with what is defined in the shape object, and sure enough, the second shape is a square, so everything looks good. Obviously, this code doesn't go so well with more than 2 shapes in terms of the isRound property, so let's add a third shape to the mix, a triangle. I have already added the CSS styling, so we only need to assign 2 classes to a div to turn it into a triangle. The triangle class and a class specifying the direction of the triangle, which can be either up, down, left or right. Well, now we can clearly see that the isRound property was not the best idea in the world. So let's get rid of it and add a more generic property which holds the type of the shape. I will name it shape. So let's say shape here, and I'll change it to a string. This one is a circle and this one is a square. We can now make the assumption that the value of the shape property will match a CSS class for a given shape. So how do we apply this class to the div element? When we supply an object as the binding to the class attribute, we specify the class name as object keys, but we need something more dynamic in this case. We can solve this by using an alternative syntax, which lets us specify an array instead of an object. This allows us to specify an array of expressions, where each expression can be a string or the name of a data property, for instance. So let's clear out what we already had and start over, and use the array syntax. So I'll add an empty array. Adding the appropriate class now is as easy as typing the name of the property containing the class. In this case, the shape property on the shape alias. So shape.shape. Running the code now will reveal that we got the circle and the square shapes working again, this time in a more dynamic fashion. So far so good. Let's now work on the triangles, so we need to add some objects to the shapes array. The class name for the triangle shape is not so surprisingly triangle, and besides that we need to specify a direction, which can be either up, down, left or right. I'll just add a triangle for each direction. So moving down here, add a new object for shape of triangle and a new direction property. Let's say this one is up. I'll just copy this and add 3 more. Like so. And I'll say right, down and left for the directions. Now for the triangles to show up, we need to add the direction as a class too, as I have added styles for the different directions within the style sheet. But wait, not all shapes have a direction. So how can we add classes dynamically? Remember that the array syntax allows us to add expressions. So we can actually add a shorthand if statement to check whether or not there is a direction property for the current shape. So let me just begin to type that out. So if the direction property contains a truthy value, i.e. not undefined, we'll add the value of the property as a class. And otherwise we'll add an empty string, which will obviously not do anything. And now we should see the triangles appear, so let's try again. And sure enough, now we see 4 amazing looking triangles. But let's take it one step further, because I want to show you something else we can do with the array syntax. Suppose that we want to apply an animation to some of the shapes when we load the page. I have already added a class named animate down at the bottom of my styles. So all we need to do is to add this class to a shape to make it animate. But first we need to know which shapes should animate. So I will add a boolean property named animate to a couple of the shapes. So let's add it to the square. I'll say animate :true and copy this. I'll add it to this triangle and let's add it to the last one as well. Alright, so now we actually face a small problem. How do we add the animate class to the shape depending on the truthiness of the animate property? Since we know the name of the class, we could use another shorthand if statement, but I want to show you a cleaner way of doing it. We started out by adding an object as the binding, which allowed us to toggle classes based on a boolean value. This would be of use to us right now. So luckily, this is also possible with the array syntax. What we can do is to add an object following the same syntax as we saw earlier to the array. Since we want to toggle the animate class, we will use this as the object key, and the value will simply be the animate property on the shape alias, which contains a boolean value. So let me begin to type that out for you. So I'll add the object here as the next element within the array and use the animate key and the shape.animate property here. If the property does not exist, the evaluation will be false and the class will not be added. When I run the code now, notice how 3 of the shapes animate, because the animate class was added to those shapes. As you can see, the array syntax provides a lot of flexibility, as you can mix strings, data properties, objects, and more. Working with objects shares a lot of the same features as we saw in the previous lecture with the style attribute, such as merging classes referencing computed properties or data properties instead of inline expressions, and more. But since we have already seen this, I don't want to take up more of your time by showing you the same thing again. Now that we have gone through a few examples of how to apply styles to HTML, it's time to use this knowledge in practice by solving a few exercises. It's time to exercise what we just covered about styling HTML elements. For the first exercise, you should bind the shape styles data attribute to the shape div elements style attribute. Then add a click event listener to the element itself, such that when you click it, its shape changes from round to squared or the other way around. Just to give you a small hint, you can use the border radius CSS property with a value of 50% to make the shape round. Also, you should manipulate the object with the Vue.set method, because using square brackets won't work, as we discussed earlier. The second exercise is perhaps slightly more challenging. Perhaps you remember the table with employees from a previous lecture. Let's make this table a bit more interesting by highlighting every second row. I have already added a class for you to apply to the rows. As a hint, you can use the loop index that the v-for directive provides, along with the modulus operator to check if the class should be added to a given row. And with that, I wish you the best of luck solving the exercises, and I'll see you soon with my solutions. Alright, I hope it went well for you. Here are my solutions. For the first exercise, I'll begin by binding the shapestyles data property to the style attribute by using the vbind directive. So vbind :style and shape styles. Since the object is currently empty, this doesn't really do anything. Let's change that by adding the click event listener that's going to switch between a circle and a square. So v_on: click, and I'll name the event handler change shape. And now for implementing this method, I'll add the methods object and change shape function. Within this event listener, I'm first going to check if there is a key on the shapestyles data property with the name border radius. That is the name of the CSS property that I'll use to make the shape round. I'll check this by checking if the type of the key is not undefined. So if type of this.shapestyles, and I'll check the key with the square bracket syntax, border radius. So if this is not undefined, then it means that the shape is currently a circle, meaning that we should turn it back into a square by removing the border radius CSS property. Now, as I hinted in the exercise description, I cannot delete the object key with the square bracket syntax, as Vue.js cannot react to this. Instead, I'll use the Vue.set method as we have previously seen. The first argument is the object that we would like to change. So Vue.set this shape styles. The second argument is the key, which is border radius. And the third is the value. In this case, I will set the key to undefined, as this is required by my if statement, and because this will cause Vue.js to not include the CSS property in the DOM. This should take care of changing the shape from a circle to a square. If the if statement evaluates a false, I need to convert the shape the other way around, which I'll do by setting the border radius key to 50%. So I'll use Vue.set again, with the shape styles data property, the same key, and I'll set it to 50%. Now I should be able to switch the shape by clicking on it. And indeed this works, so that's it for the first exercise. Moving on to exercise 2. As I hinted in the description, we need to make use of the loop index here, so I will add that to the v_for directive first. So let's go ahead and add the parenthesis and the loop index. It's true that one could accomplish this with pure CSS3, but we won't do this for the sake of this exercise. Now that we have the loop index at hand, we can bind an object to the class attribute with the vbind directive. So vbind class and an empty object for now. Since we want to conditionally add the highlighted class, I will add this as the object key and let the expression determine whether or not it should be added on a given table row. So I can add highlighted as the key here. And for the expression, I can use the modulus operator to check the remainder of dividing the loop index by 2. So I'll write loop index %, which is the modulus operator, and 2. So if the remainder equals 0, I will add the class, which is going to be the case for every second iteration of the loop, starting with the first row. So if the expression stating that the remainder should be 0 is true, then the highlighted class is added, otherwise it will be discarded by Vue.js, because keys that contain a falsy value will not be added to the DOM as classes. Actually, that's all we have to do in this exercise, so we should now see a background color on every second row in the table. As you can see, this exercise was not that difficult as long as you are familiar with the modulus operator. That concludes the lectures on styling. Before ending this section of the course, I just have one more thing to show you, something that can save you a bit of typing and therefore time. So, see you in the next lecture. I'm sure you noticed by now that we use the v-on and v-bind directives quite a lot in Vue.js. Wouldn't it be nice if we didn't have to type that out explicitly every time? Fortunately, Vue.js provides shorthand syntaxes for these two directives. Let's use a button with a click event listener as an example. Instead of prefixing click with v-on and a colon, we can simply replace the prefix with an @ sign. Therefore, we can simply write @click equals and an expression. So let me just do this on this button right here. So I can write an @ sign, click, which is the name of the event, and the expression is the same as always. So running the code, we'll see that both buttons give the same result. So the @ sign is used for events, followed by the name of the event. Similarly, we can shorten the v-bind directive syntax as well. The shorthand for this directive is simply a colon, followed by the name of the attribute to bind to. In this case, we're binding to the title attribute, so we just write colon, title, and the expression. So let me do that on the second paragraph down here, colon, title, and the expression is going to be the same. So if I hover my cursor over both of these paragraphs, you will see that the result is the same. While this syntax may look strange and unlike any other HTML markup you have seen before, these attribute names are actually valid HTML attributes, although they won't actually do anything without Vue.js. Like I said, it may look a bit strange at first, but don't worry, it's not going to appear in the markup that's rendered once Vue.js is bootstrapped. So if you were to inspect elements containing these attributes, you will not see any sign of them in your browser's inspector. So why didn't I mention this before, you might ask? First of all, I apologize for keeping you in the dark until now, but instead of starting out by using this syntax, it's good for you to keep in mind that when you're using these shorthand syntaxes, you are in fact using the v-on and v-bind directives. This makes it easier to understand what actually happens when using these shorthand syntaxes, instead of just using them and not knowing what actually happens behind the scenes. That being said, these shorthand syntaxes are the most common way to use these two directives, and this is also the syntax that you will see me use throughout the rest of this course. This completes the walkthrough of the fundamentals of Vue.js, and thereby this section of the course. Of course, there are more fundamental concepts of Vue.js, such as components and forms, but subjects like these are quite big and will therefore have their own dedicated sections. In the next section, we're going to put all of this theory into practice by building a sample application. So, see you there.